So, given a vector field, is there an indefinite integral, a function? Well, the answer in Calc 2 was very easy. For any function, there is antiderivative. Isn't that right? If I give you any function, can you find antiderivative? Well, is it possible to find the antiderivative in Calc 2? Or do you know a function that doesn't have antiderivative? You know, that's a fundamental question. So let's recall something from Calc 2 then. I give you a function, f of x. Can you find another function such that derivative of that is equal to the given function? E to the x? Well, you're talking about an example, right? So for some examples, I give you a function you can integrate. Because you know some formulas, how to integrate exponential functions, polynomial functions. What if your function, what if this, oh, okay. E to the x to the tan of x. Can you find the antiderivative? What is that going to be? The same function? Well, can you check that? By differentiating. You should be able to differentiate that function. And the derivative will involve the chain rule, so it will be the same function times a lot of things. It will definitely not be the same function. So there are many examples when you cannot effectively compute the antiderivative. But the question is, I think, fundamental. Is there a function? Although you cannot write a formula for that function, maybe just because you don't know the formula, but is there a function?
Well, the function doesn't have a derivative.
What if this function doesn't have a derivative?
No, if like
that function?
I guess never mind, but it has that.
Yeah, you wouldn't even consider that, right? So, can you find a function that has derivative? And that derivative is equal to that function, to the function I give you. You remember the fundamental theorem of calculus? Don't you think that an answer to a fundamental question should be a fundamental theorem?
You take the integral of the function and have that equal big F of x.
So you integrate from something to, well, maybe I should use different variable here. Integrate from 0 to x, and then you say this is the function f, right? Well, this is a definite integral, and that you can compute for any function, right? You just subdivide, you add those sums, you get approximation. If you want better approximation, you can do it better. So that is a very computable thing. So you have a value for every given x. So that means you have a function. What makes you think that derivative of this function is f?
So you have to evaluate.
Because that's the fundamental theorem of calculus. Derivative of that with respect to the upper limit is the Nikolay of x. So calculus 2 tells you that for any function there is antiderivative, it also gives you precise formula. In terms of integration, not in terms of simple operations like exponentiation or power.